Welcome back to part 2 of our 3.1 notes. And we're going to start talking about solving by factoring because we love factoring. We can use factoring to help us solve quadratics. And a reminder, when we're solving quadratic equations, we're finding the x-intercepts, roots, solutions, or zeros. Those are all the different terms that various places use to talk about finding the x-intercepts. Let's start with our factoring. We're looking at this factoring problem and saying, is there a common factor between the 1, the 12, and the 35 that I can reduce all three of those numbers by? The answer to that is no. So we have 1 times 35 is 35. We need the factors of positive 35 that add to positive 12, which are going to be 7 and 5. Now remember, if you have a method of factoring that you love best, that's what you're using to factor. Otherwise, we introduced this factoring by grouping method way back in section 3.0. And we're going to split this in half. Our common factor on the left side is x, leaving us with x plus 7. The next section starts with our addition sign, and our common factor between 5 and 35 is 5, also leaving us with x plus 7. So the x plus 7s being exactly the same in those parentheses means I've done my factoring correctly. And that's one of my answers. And the other answer is the greatest common factors that we pulled out, x plus 5. So let's take a minute in your graphing calculator if you have one, or on desmos.com. You can put this quadratic into your graphing calculator and graph it. When I do that, sketch my graph here. When I do that, my graph looks something like this. So the question is, what do we notice about the factored form that we had, which was x plus 5 and x plus 7, and the x-intercepts that we have on our graph? Well, it certainly looks like our x-intercepts are at -7 and -5, which are the same as the x plus 5 and the x plus 7, just opposite signs. Coincidence? Definitely not. So x-intercepts in the factored form that we have the same values but opposite signs. The reason why is when I look at the y value of one of our x-intercepts, for example, at the -5, our y value is 0. And that's going to be the case every single time that we have an x-intercept. And so we use something called the zero product property, meaning that if any one of our expressions is 0, then the whole thing is equal to 0. And this is what we're going to use to solve using factored form. One other thing to remember is to make sure, use my highlighter here, that all the quadratic equations are equal to 0 before you start solving them. So let's try some. Here we go. Example 1. I'm going to factor Start by checking, is there a greatest common factor between 1, -8, and 12? And no, there's not. So 1 times 12 is 12. The factors of positive 12 that add to -8 are -6 and -2. So you're going to use your most favorite factoring method. And we get x minus 6 and x minus 2 for our factors. Now that's factored form. To solve, we're going to take each of those factors, set them equal to 0, and solve for x. So we would add 6, and x is equal to positive 6, and then add 2, and x is equal to positive 2. So our zeros, roots, solutions, x-intercepts for this quadratic function are at 6 and 2. Example 2. 2, 11, and 12. Are there any greatest common factors that we can pull out? No, because the 11th, I can't divide that by 2 evenly. So 2 times 12 is 24. We need the two factors or numbers that multiply to positive 24 and add to negative 11. So that will be -8 and -3. Again, take a minute now and do whatever factoring method you love most. And you should get 2x minus 3 and x minus 4. Again, that's factored form. So to solve, 2x minus 3 is equal to 0. X minus 4 is equal to 0. Add 3. 2x is equal to 3. Divide by 2, and we have x is equal to 3/2. Over on the right, we're going to add 4 to both sides, and we get x is equal to positive 4. So our x-intercepts, roots, zeros, solutions are at 3/2 and 4. Example 3. Well, notice in example 1, we were equal to 0, and we mentioned that on the previous slide. Number 3 is not equal to 0, so this should be equal to 0. In order to do that, I need to move the 45 over to the left. The opposite of a positive 45, to move it, is a negative 45, and we end up with x squared minus 4x minus 45 is equal to 0. Remember, I can't actually subtract the 45 from anything over there because it has no like terms. Now that it's equal to 0, we're going to check for a greatest common factor between 1, 4, and 45. And there isn't one. So 1 times negative 45 is negative 45. We need two numbers that multiply to negative 45 and add to negative 4, which would be -9 and positive 5. So again, take a minute, do whatever your favorite factoring method is, and factor this problem out. We should get x minus 9 and x plus 5 as my factors. That's factored form. To solve it, you set each of those equal to 0 and solve for x. So on the left, I'm going to add 9 to both sides, and I get x is equal to 9. And then on the right, I'm subtracting 5 from both sides, and we get x is equal to negative 5. So 9 and negative 5 are our two x-intercepts, the zeros, roots, or solutions. Alrighty, last but not least, number 4. So is it equal to 0? Yes. And then again, the same question that we're asking for every single one, is there a greatest common factor? And in this case, there is. I see an x in both of those terms. So x is going to be my greatest common factor. When I pull that out, I'm left with x minus 8. Well, I don't have any other factoring to do because inside my parentheses are only 2 terms, and there's no more square in there. So every x gets set equal to 0. So this x on the outside is set equal to 0. The x minus 8 on the inside we set equal to 0. The one on the left is already solved. X is already alone. So 0 is one of my intercepts, roots, solutions. X plus 8, we're going to add 8 to both sides, and we get x is equal to 8. Now remember, I'll highlight this here. You can check your answers on your graphing calculator. If it's a whole number, then those intercepts, roots, solutions, or zeros will be visible on your table as well as on your graph. Okay, but we still want to see your work. Also, make sure you pay attention to the fact if the question is asking you to factor or to solve. Okay, factor or to solve. We will take care of the bottom 2 try-sum problems in class tomorrow. Have a great night.